Hello, everyone. I would like to talk to you today about a few topics on the 5G Open RAN. In particular, I want to hit the themes of really disaggregation, virtualization, and standardization. And without the standards, it's really hard to see any of this stuff ever happening. So my role at Qualcomm is leading the team that's defining the Open RAN standards in various forums, which I'll discuss a little bit in a minute. And let's start off with a level setting slide that talks a bit about the history of the RAN and how we got here. Essentially, the radio access network connects mobile devices to the internet. And when I first started working on these things many years ago, we were talking about connecting devices to the telephone network, if anybody remembers those days. But now it's all about the internet, and it's been a pretty clear evolution over the last 25 years or so from this fully integrated cell site model where you've got your baseband processing and your radio heads together at the cell site. It all comes from a single vendor, and then you simply have backhaul into the core network. And again, back in the old days, we were talking about T1, E1, which is pretty slow backhaul, but now everything is over fiber, given the massive amount of data that we can handle with 5G networks. So I'd say maybe 20 years back, we started to see the emergence of the split between the baseband processing and the radio units. There was a standard defined called CIPRI, which allowed for really simple remote radio heads to be deployed at the cell sites, and then have what's now called the front haul between the centralized baseband and the cell sites. And again, this was all single vendor deployments, and it's what we term centralized RAN or CRAN, which is sort of a confusing acronym because now we're talking about Cloud RAN, which is the same CRAN acronym, but Cloud RAN is really the same thing as virtualized RAN, where you're taking those RAN workloads that previously ran on bespoke appliances that were really designed just to run those workloads, and you're putting it on off-the-shelf hardware and servers that can run various workloads for the cloud or for RAN as shown here. So now we're in the more recent history where these edge cloud deployments can include mobile edge computing, virtualized core networks, virtualized, again, RAN processing with more disaggregation that allows for the BBU to be split into a CU, DU, and then the remote radio units out at the cell sites. So this architecture, again, can come from a single vendor, or if we look to Open RAN standards, you can now do it with multiple vendors supplying different parts. So let me skip to the next slide here, which really is talking about disaggregation at various levels of the architecture. We're disaggregating the hardware and software for the access network. We're disaggregating different layers of the protocol stack. You might have heard of functional splits. So you can split the architecture at various points, split 2, split 6, split 7, and again, even split 7 is evolving within the ORAN Alliance to allow for new capabilities as we go forward. And then, of course, the control plane and user plane functions have been disaggregated already by 3GPP in the core and at the CU, and in certain parts of the ORAN architecture, we're doing the same thing. So disaggregation and, again, virtualization, or moving the workloads to commodity hardware are two key points of 5G Open RAN. What this is driving is allowing for a wide range of deployment scenarios and base station classes where you're putting the processing and analytics where it's needed, and we're simplifying the orchestration, again, by having a standard architecture and standard interfaces. Allows also for better scalability and utilization of resources. We're centralizing some of these resources into more the core of the network or the edge of the network that allows for resource pooling and gains of sharing those resources among multiple radio units or cell sites. And that also allows you to scale with the virtualization to use resources to allow for additional capacity where it's needed. The next point of deploying new services efficiently, I'd say it also is talking about deploying infrastructure more efficiently and commissioning base stations and radio units more quickly. It allows for the components to be evolved separately and for different vendors to do what they're best at doing, and to be used both for public networks and private networks, which are emerging now. We're starting to see the Open RAN concepts used for private networks as well. Allows also for more dense networks to be deployed more quickly because, again, the radio units can be done in a more compact way. We're seeing a lot of new hardware being developed according to the O-RAN standards, and that allows also for lower power consumption using less electricity, which everybody wants to see. And the last point is something that might be not appreciated as much as it should be, but we've seen in previous generations of cellular infrastructure, sometimes it's been a little difficult to get certain features deployed because there's been a lot of consolidation in that industry, and you have to convince a couple of big companies to essentially build a feature that may have utility for one or two operators, or not everybody's on board with it yet, so it's hard to get those things done. But here we're seeing with Open RAN the ability to spur that innovation and to really get features done in a more speedy way to get things out into the industry, and to allow, again, for suppliers that have certain skills to really capitalize on that and get their products out there. This slide, I could probably spend the entire 50 minutes for this talk here, but essentially it's showing the role of standardized open interfaces to enable 5G Open RAN to happen. So we're broadening this interoperable ecosystem, allowing for a lot of new companies to come in. We're seeing really excellent new products emerging. If you looked at some of the MWC announcements from a month or so back, there's products at really everything here on the DU and RU side from multiple vendors. So going from left to right, really 3GPP has obviously defined the overall 5G architecture, and they define a lot of the interfaces that are used in Open RAN as well. So any place you see here a 3GPP bubble in the architecture, the F1 interface, the NG to the core network, some of the X interfaces, which are not shown on this slide, are also from 3GPP, and also the CU split for in the DU is, excuse me, in the CU is defined by 3GPP. So O-RAN has really stepped in to fill the niche that the operators were asking for in terms of open interoperable interfaces in the radio access network. And only some of those interfaces are shown in this architecture diagram. The key ones here are between the near real-time RIC for AI control of various nodes in the architecture, and the open front haul, or the CUS split between the DU and the RU. That's the so-called option 7.2X, which is fully specified by O-RAN. There's lots of interoperable implementations existing already, which is really great to see. The other part that I want to highlight is the role of the small cell forum, which is defined option 6, or the MEC-PHY split. That's used both within DU platforms today, as well as there's been some examples or demos of using that FAPI split on the front haul. So you can actually do an option 6 front haul as well as the option 7.2 front haul. Okay, a lot going on here. I'll explore some of these things in further slides. I think Aitor actually covered the RIC platforms pretty well in his keynote a few minutes ago. essentially, the RAN intelligent controllers, or RIC, work at two levels: the non-real-time RIC and SMO, which do more service management, orchestration, network automation type features, and then the near real-time RIC, which does control again over the E2 interface of the CU and DU platforms. And really, this the key things that the O-RAN Alliance has done is defining the architecture, defining how RIC platforms can be used to provide both new features and this network automation role, as well as defining all the open interfaces that allow for these things to be deployed with multiple vendors. So some of the things that are happening here are collecting data to train machine learning models, and then deploying those models and allowing for inference and both non-real-time and near real-time control of the other platforms in the architecture for various use cases. What's not happened yet is the so-called real-time RIC, which would happen within the DU and RU platforms, but that's sort of the next step, and we expect both in 5G and 6G to see that happen. One other thing I haven't talked about much is the processing of the hi-fi layers within the ODU. And the O-RAN Alliance has actually defined two different architectures to allow to offload CPUs in the DU to accelerate these functions in hardware. So one model is look-aside acceleration, which allows for selectively offloading functions, which would then be passed back up into the CPU and then sent out on the front haul interface. And in practice, we're really talking about forward error correction here, although we've actually seen recently some vendors sort of reintegrating those functions into the CPU. So it's been an interesting evolution of look-aside acceleration there. We also see multiple suppliers now doing full inline hardware acceleration of, again, these hi-fi functions in the DU. And this can be done on GPUs, FPGAs, or ASIC platforms. And essentially what happens here is you have a clear interface through O-RAN from what we call the acceleration abstraction layer, or AAL, to these inline accelerators, and essentially all of the 5G signals and channels can be sent directly to this accelerator, which includes all of the hi-fi functions as well as the network interface. So you can think about the pluggable optical interfaces that come from the front haul. You can plug it directly into these accelerators and essentially remove some of the parts and complexity from the old architecture that was defined for the DU. So performance, power efficiency, again, we've seen demos showing very low power consumption of these accelerator cards, at least one that I'm familiar with from Qualcomm, that was shown at MWC last month. And that's pretty attractive for the operators and for certain use cases. All right. I'm going to summarize here and sort of recapitulate the overall talk with a simplified version of the architecture. So what is O-RAN allowing for? It's allowing for vendor diversity, for new entrants to come into the market. We're, again, if you look at the list of companies that have joined the O-RAN Alliance in the last few years, there's about 300 in the sort of supplier researcher community. There's about 30 or 40, I think, now in the operator community. The operators have been asking for Open RAN equipment for many years now. We were confident that 5G will be the G where we see wideband deployment of Open RAN. We've already seen several greenfield operators such as Rakuten Dish, 1&1 in Germany, really basing their entire networks around Open RAN. And we're hopeful to see more brownfield deployments in the near future, where some of the major operators are doing a lot more with Open RAN. So the key things that are enabled again are machine learning and AI control of the radio access network. And again, these open interfaces that allow for best of breed suppliers to come with new hardware and new platforms that really meet the requirements for various deployment scenarios, again, and base station categories that operators are looking for, everything from small cells to massive MIMO macro cells, and in every band that you can think of, from sub-6 to millimeter wave. The other key thing I wanted to mention with Open RAN is we're seeing good velocity in terms of the development of new features and development of the standards themselves. It's really a continuous meeting. The O-RAN Alliance never stops. It's more of a CI/CD type model where things are continually being developed and improved over time. I think I'm probably about out of time, so I'll wrap it up here. Thank you.
Thank you, Jack. That was great. Looking forward to seeing you now in our panel discussion, which is moderated by Monica Paolini from Sensafili. Monica, please take it away.
Thank you so much. It's a pleasure, and I actually got my job to be really easy today because we had two excellent presentations that have been covering all the background on what's going on Open RAN. But I'm equally blessed by having three great panelists with me today. And I have Jack Nasielski that you just heard from Qualcomm. He's a senior director, wireless R&D. Then Sushil Rawat from Rakuten Mobile, VP of vRAN, of the vRAN platform at Rakuten. And then Franz Seiser, who is the VP of Access Disaggregation, Deutsche Telekom. And the title right there tells you a lot about what he's working on. And so what we're going to try to do in this panel is to sort of try to look at what's happening today, what we've learned, where we're going. So it's like try to make a point of like, where are we at? Because with Open RAN, it's one of those topics that it's really a hot topic, but it's also a topic that gets a lot of people, very active one way or another. People that love it, people that hate it, very few people in between. And I think that what we can do today is to try to kind of bring some reason to this and sort of think about what we've learned, where are we going. So what I would like to ask is our great panelists to give us a brief introduction of who they are so that you in the audience get some context and can ask questions. It's very important that you guys ask questions as soon as you can. If you get questions in and they're relevant to our discussion, I will bring them in. But otherwise, we'll have a Q&A at the end. It's really important because we want to hear what you think about it, what your questions you have. They're very important. Otherwise, I'll go ahead. I have plenty of questions for them, but it's much better to hear questions from you guys. So why don't we go? Okay, why don't we start with Jack? I mean, we just heard from you, but maybe if somebody's just jumped in, can you tell us what is that you do at Qualcomm?
Sure. Yeah, I'm in the standards group at Qualcomm, and I work very closely with our research group as well. I've actually bounced back and forth between research and standards over the years. I've been working in cellular since 3G, and now we're ramping up to 6G. So it's been a few years, and at every one of those Gs, we've actually tried at some point to introduce openness in the radio access network, and it's always been a failure until now. So I'm one of the people who love Open RAN. I understand there are a few out there who are haters, but I'm here to convince you that 5G is going to be the one where Open RAN actually happens in a big way.
And if I may add, openness is more than Open RAN. It's just really like it's a bigger project, and it's worth thinking about it that way, I think. Sushil, how about you?
Good. How are you? So
Right.
I was currently I'm leading hardware development and Oran ecosystem, which is basically helping uh, suppliers and our software teams to put together a solution that can be deployed to delivered to customers. I've been with Rakuten for almost 4 years and a half now, and I was actually at the forefront in Japan, building. I was leading the Open RAN team. As previously mentioned, we are one of the largest Open RAN operator today in Japan, and we are definitely on the liking side of the ORAN because we bet our entire company strategy on it. We would like to see more and more people in the middle category so that they come with a thought process of learning whether there is something good in going on with the ORAN or not. So we had done a lot of deployment and integration work there in Japan. There are lots of learning which we'll be discussing in the panel today.
Absolutely. And just by coincidence, today I was at the launch of your UK lab, and it's quite impressive. So it's just Japan is step number one, but you're next to wider um, landscapes. Franz, what about you?
Yeah, so hello everyone. My pleasure to be here. I'm Franz Seiser. I'm in DT Group Technology Organization. Today I'm joining you from the nice city of Prague as I'm meeting my team here tomorrow in person. So bear with me. I hope the hotel Wi-Fi is good enough and we come through that session. So personally, I'm now in my third year of running the DT ORAN program. While my background is much more on core and cloud, so I already had all the pleasure on Etsy NFV and virtualization of the core network. Some roughly 2.5 years ago, I changed over to ORAN and bring all the learnings from them into the radio space. I can tell you I had quite some déjà vus. Somehow we love to go through the same learning curves again and again. But I think we came pretty far. I'm sure we'll discuss that a bit further as this panel goes on.
So are you based in the Germany part or Poland?
Yeah.
Or
So I am located in Germany, in Bonn, in the headquarter. But as our team is pretty distributed, so already before this whole Corona crisis thing, we worked rather distributed, and now we're doing it even more. But luckily, we can meet face to face again, and I'm really looking forward to see the guys tomorrow, as we still have some work ahead of us. Because what we started 2.5 years ago was a very clear ambition. We said we make ORAN a commercially deployable option for all our networks in Europe, being able to deal with all the complexity we have in our network. So for us, it goes far beyond 5G. It definitely includes 4G, and as we are in Europe, I'm afraid we also need solutions for 2G still. So this is one of the complexities we come across. 5G only ORAN is a little bit easier to build, even though there are more than enough challenges, especially if you look at massive MIMO, but we have a few things more to put on top that need to be solved.
Yes, you are right. And so what we're going to start today is talk about the relatively easier win for Open RAN, if I may say so, Sushil. Because at Rakuten, you're a greenfield operator. So I'm not saying that choosing Open RAN is an easy choice, but it's somewhat easier to go Open RAN when you start from scratch. But still, can you tell us, what is that, so you have the largest commercial Open RAN, I believe, in the world. So can you tell us, what have you learned so far? Where are you at on that?
Sure. So before I will go into that, I would just like to explain when I say largest Open RAN network, the scale of it, right? So Rakuten Mobile have close to 50,000 4G sites, and close to 20,000 5G sites running on Open RAN today. And it's been running for almost 2 years now, with quality standard that is expected in Japan. Uh, to be honest, if you go, all the operators in Japan are doing extremely well in terms of performance. And you will see the experience of mobile network in Japan is a notch ahead, right? So there was when we started building this network back in 2018, there was lots of challenges. One of them predominantly was the ORAN alliance standard itself was not completed. It was still work in progress. uh, Barely anything in the ecosystem, right? So hardly any RU suppliers. It's just standard servers, very few options. But we decided to get started somewhere, right? And we were fortunate enough to have suppliers like Nokia and other software partners, which took the opportunity and we came up with an open mindset where they wanted to try this. So we could deploy this network. But one of the biggest challenges, I would say, and everybody to expect, when we talk about openness, it's basically taking up all the components and ripping them apart, as you probably saw on the slides from Aitor, and also from our standardization team, as Qualcomm member was saying. When you rip apart everything and then you see multiple different pieces on the floor, somebody has to put it together, right? Now you can look at it as a system integrator's job, or you can look at it that, okay, now I have to put it together. So this was one of the biggest challenges, and a different mindset that has to come together, right? So we decided to take that responsibility, and we started to putting together things, and took the responsibility of a system integrator. Quickly we realized that you can put together a solution for few sites and for POC, but when you have to do a massive deployment of a network, scalability and automation is the most important part of this process, right? And that's where I thought, and others was also putting a lot of focus. Vodafone, Qualcomm, and other groups are also putting focus on packaging the whole solution, because not every operator may be willing to take that kind of responsibility. Everybody have a different business aspect and thought process in terms of running the organization. So that is one very critical part of a system integration and automation, where the standardization piece of multiple interfaces also plays a very, very important and key role, right? So those are areas that we found was very challenging. We addressed those, and today we have a network which is scalable enough. I would say we have close to 70,000 plus sites, 4G plus 5G put together. We have reached that kind of a scale with the responsibility that we took on ourselves for becoming a system integrator and automator.
Absolutely. And that, you learn so much in the process because you're clearly, ahead. But the challenges that Franz, you are looking at are somewhat different because, as you say, you have anything from 2G onwards. And so to add Open RAN on top, to layer it on top of that, it's a kind of like it's the same solution, but deployed in a very different context. So, what is it you can take and extract from this, and what are the challenges? Where are you going right now? So you have a clear commitment, but how does it work in your network in practice?
Yeah, you are totally on the point. So our issue obviously is, as we are the market leader in most of the markets we are active, and our top management is very keen to keep that position. Even when we started our journey, the first thing I heard from all the CTOs is, sounds interesting, we are all in, but our precondition is the customer experience does not change 1 single millimeter. It can get better, that's okay, but we have for sure will not accept it's getting worse by any mean. And as we are deploying state-of-the-art technology, obviously that barrier was set pretty high from the very beginning. And as we just learned some 2-3 years ago, Open RAN was still in its infancy, especially when we started talking really complex deployment scenarios. I mean, 2G is a topic in itself anyhow, there you need to find a solution. There we don't insist, but for 4G, 5G, it was clear we want to have a full Open RAN solution, which consists of, as we always said, number one priority, open front haul. That goes quickly together. If you want to really master it, a third-party management system, and number three was virtualization of the baseband. Yeah, and then we started our famous O-RAN town. I think everyone who followed the technology someone came across it. We had all the fun you can have with that kind of deployments, because again, we started basically on a white sheet of paper. Then also this whole component crisis kicked in a little bit and made our life not exactly easier, to say it like that. So it was really a long learning journey. It was a little bit 2 steps forward, 1 step back. But I have to say, finally we arrived. Maybe not 100% where we wanted to arrive, but that was part of the planning anyhow. It was really impressive to see how the learning curve of the technology accelerated over that time. So more companies came in, more learnings came in, more activities. We had then the MOU we founded with our other peers in Europe. We really saw we all share a common target. We all want to achieve the same thing. So that really already helped. And I think it really, the top point for me was then Barcelona this year, because when you went through the show, everyone who was dealing with radio had O-RAN on the booth, and the discussion only was when do we deploy, but not at all anymore if at all it will happen. So for me, it was really very clear. All the key players in the industry are convinced O-RAN is the way to go, and this is going to happen. It's just a question how soon it will come, and also that we experienced. So and we did our announcement there that we will start with small-scale commercial deployments. On the one side, I'm pretty happy about it. On the other side, I'm also open. Our initial plan was more ambitious, but because of the learnings we had to scale back a little bit and reduce the size. So our current assumption, and we also published a nice white paper the week before Barcelona to be found on our website, where we really summarized the learnings and the issues we still see. And also there was a good summary on the way forward from the MOU. So there's also very good guidance, I think, from the operators. So there is still a little bit work to be done to really be ready for large scale deployment in brownfield networks. Our ambition very clearly is we want to end up at this point latest by 2025. So in some 2 years from today. Why? Well, it's pretty easy to explain, because this is when the next big wave of network modernizations will start. And we want to be really in a position that by then this target is achieved. O-RAN is a fully competitive, commercially deployable solution to whatever else is available on the market, as well as we as a company, we are ready to deal and deploy the technology, because as was already explained in the presentations before, the biggest thing, of course, you need to deal with is this whole topic of integration complexity. Because easy thing, if you're tearing things apart, is pretty easy. Putting it together in a way that it works like you want it to work and delivers the performance and the customer experience you expect, that's a slightly more difficult thing. And there is still quite some work ahead to master that and do that in a way that is most efficient and most done jointly in the community, because we have no interest as DT to do everything ourselves in our own labs only for us. This, we believe, must be a much more distributed and joint activity of the industry.
Yeah, and I think your comments are really great in terms of being honest in acknowledging that not everything is perfect, and it is true of everything new you try to deploy. And being able to acknowledge it as you move forward, you still keep the commitment, but you also keep the honesty to everybody in the ecosystem and your subscribers. And I think it's very valuable. And I think that this is what we have been seeing, or that's what I've seen in the last few months or last year, where people are really having more of a honest assessment of the opportunity, but also as to the work that we need to do in order to get there, to realize that opportunity. And so, Jack, you give us a great introduction and background on Open RAN. Maybe can you tell us a little bit about how do you see the role of Qualcomm in the ecosystem? Because Open RAN, it's really, I would say the success of Open RAN depends on having a good ecosystem. Nobody can do it on their own, so by definition. So how do you see your role to Qualcomm to be?
Yeah, absolutely, Monica. That the ecosystem is critical here because it requires the companies to really provide their best. You know, the skills that a given company has and their technical expertise can be focused on the areas that they can provide the most value with Open RAN. And then this integration problem that the previous speakers mentioned is really, you know, it's a problem, and it's also a good thing because it allows you to sort of collect all of these pieces from the specialist. Now Qualcomm's role is growing, and I hope it'll grow a lot more in the future. If you look back to 3G and 4G, we developed a business selling modems and RF front ends and radio parts for small cells. And that is carrying forward into 5G. Obviously, we've got new platforms coming along there. And in some ways that solves some of the integration problems because a lot of the small cell deployments are all in one. They're sort of integrated, and the interfaces from O-RAN are within the box. It's more of an option 2 sort of interface. But our ambition there is really to use the Open RAN standards that we've developed to allow entry into macro base stations, and using the parts that we've developed really from a clean sheet of paper to be compliant with the Open RAN standards, both for the ODU for accelerator cards and at the RU to terminate the front haul through the lo-fi processing, the transceiver chips, the millimeter wave modules, really everything you need to build an RU. We can provide most of those parts to suppliers. So we're enabling hopefully a lot of new suppliers to come up on the ORU side for macro, micro, you know, again, any type of base station category you can think of between our small cell platforms and our new platforms, what we call the QRU and the QDU. We can span the entire hardware requirements that are out there. The other exciting thing that Qualcomm is doing for the ecosystem is, if you consider, again, Aitor's presentation talking about network management, automation needs from the operators, we've acquired a company about a year ago called Cellwise, which is already deployed in, I think at last count, it was around 30 different operators, that allows for both supplying those functions to operators as well as this key aspect of managing multiple suppliers or providers of radio equipment in the RAN. So we can give an operator sort of a way to manage equipment that comes from, again, different suppliers. I won't list them out here, but we've integrated multiple RAN suppliers under that umbrella of network management orchestration, which is essentially the SMO non-real-time RIC within the O-RAN architecture. So that is something that Qualcomm had not done before this acquisition, but it's a pretty exciting thing that we're involved in now. We're seeing a lot of interest and uptake from the operators in that space. So we've got a lot of product interest now, and we also, for the ecosystem, are helping in various ways to develop the technology through standards and other industry organizations that we're involved with.
Yes, and I want to go to questions from the audience, but before we go there, let's just talk about a little bit about standards and how important it is. How much work do we still need to do? Actually, why don't you start, and I might have some follow-up questions for Jack. Why don't you start on that?
How much work we still need to do?
Doing on standards.
I think the standards overall are in pretty good shape for, again, the 5G Open RAN and even 4G from the O-RAN Alliance, and especially things like the Open Front Haul, which O-RAN actually inherited 4 or 5 years ago from the X-RAN forum. So that has been, it's essentially being maintained now through CRs, and new functions and features are being added to it. But the ability to have two vendors come together, do multi-vendor interop testing exists. There's OTIC testing labs, ORAN test integration centers around the world, which have proven this. That standard is, I would say, rock solid, ready to go. The other things around the RAN intelligent controllers, I think, are also maturing over the past few years, and we're getting to the point where we're starting to see testing of those platforms as well. So I'd say that the overall ORAN architecture, there are parts that are more mature, parts that are less mature, but the standards are certainly on the right track, and the things that are left to be done, people are working on those day to day. And as I said, it's sort of a continuous process with ORAN, in that the meetings are happening almost every day of the year. We take off for Christmas and for Chinese New Year, and otherwise we're working constantly.
Absolutely. Sushil, do you want to add anything to this?
So standardization has already played a lot of important role in developing Open RAN, but I would say taking this further, making it strong enough so that it can be adopted in a brownfield network, is where we have to look for. Now, ORAN Alliance, Small Cell Forum, and multiple other organizations have done a great job in terms of putting together a standard that multiple vendors can adopt. But this also now call for having third-party labs for certification or system integrator lab, which basically in turn come up with a longer time to market cycle, right? So if you have to take 10 different vendors and integrate them with one software or multiple software release, so software release, the solution time to market become way too longer. What should eventually happen is there should be a southbound flow of these standards into 3GPP, where certain interfaces like front haul should become more of a 3GPP standard than a ORAN standard. When it becomes a 3GPP standard, it automatically become kind of a necessary requirement for all traditional vendors and new vendors, and that we should target it to become a S1 type interface where any EPC can interconnect with any node B, right? So that should be our target, and that is when more brownfield operator will more open-heartedly embrace Open RAN, I would say, because now this multiple certification, multiple labs, and this complexity of doing multiple different permutation combination is also creating a kind of not so comfortable feeling in operators, right? They would rather focus on performance driven solution. As Franz was saying, right, none of the operator would expect 1% of change in the KPI from customer experience perspective. They would always expect better than what they have today, and to get there, that's where operators focus is, right? So the standardization party, especially 3GPP, should adopt more and more standards coming in from Small Cell Forum and ORAN.
Absolutely, and there are many moving parts here. So, Franz, what's your perspective?
So Sushil, I hear you. Fingers crossed. Hopefully with 6G we get that moving, because I mean there's a reason why ORAN Alliance exists, and that of course has something to do how much it was embraced in the early days by the big 3GPP players. But coming a little bit back to ORAN Alliance, I mean as many of you probably know, the chairman of the ORAN Alliance is my dear colleague Alex Choi. So we as DT, we are extremely strong in there, and we are co-founders. So I think many things, as said, are working good, especially open fronthaul. Yes, there's a discussion, do we need to do something for massive MIMO? That is still ongoing. I think where still more work is required is on the one side, the management interfaces, O1, O2, and especially O2 is still a little bit in its early days for various reasons. So that's the one. And the other one, as we have been talking about RIC before, also especially the interfaces around near real-time RIC. That's the second big construction site, I would say, we still have to get sorted. It's not mandatory for early deployment, so it's not super critical. But of course, if you look what we want to achieve in 23, then I would really name these two things. So getting the O1, O2 really fully matured and making significant progress on E2 and the like.
Absolutely, and Rick, it might not be mandated, but it's critical in many ways in terms of being able to get the full opportunities. But before, and we're gonna get to Rick because we have a question from the audience. But before we get there, I wanted to ask another question from the audience, and you guys in the audience keep asking questions. We have some excellent ones. And the question is, how are you handling the power consumption comparison with traditional E0B, G0B, if with ORAN? So, and I think that this is really an important question that to some extent goes beyond Open RAN. As you disaggregate the network, do you miss some of the optimization opportunity in terms of the power optimization, power efficiency, as you have multiple vendors that have to work together? So there is a question of, do you keep the same performance? And clearly the answer has to be yes, otherwise nobody's going to deploy Open RAN. But what about power efficiency? And maybe Franz, you want to get started there?
Yeah, I do. Honestly, power efficiency is one of the best examples to show the power of an open architecture. Because yes, in the initial days, it was clearly behind, and power consumption and security have been the two most criticized things about ORAN, and I think both have been solved. So there was no complaint. Security really is done. There was a lot of effort spent, and a lot of work is happening. So in the meantime, I think most people understood security is not an issue with ORAN, and power is now also addressed. And for that, we need to look a little bit deeper, and I think Jack then can help me a little bit. A base station consists of two pieces: the radio unit, which is up on the mast, and the baseband. Now, while in the baseband, of course, you have all the intelligence, the power is consumed in the radio units, because there you have the power amplifiers and the like. And I was always questioning, why the hell does an Open RAN compliant radio unit consume more power than a classical SRAN based? Until I learned, I said, I'm not a hardcore radio guy, so it took me some time. The reason was the IUs that were designed in the early phase were done with FPGAs, because the open fronthaul was not fully stable, and they wanted to have an opportunity to adapt if the interfaces changes. And an FPGA, unfortunately, needs more power. The next generation, which is now coming, or to some extent is already there, is using standard ASICs. And with that, the difference in power consumption is basically going away. So there is no single reason why an ORAN radio unit should consume 1 single watt more than an SRAN radio unit. But as I said, we have a silicon expert here. He can explain that one probably 10 times better than I can. The second thing, and that's even nicer, if I just can conclude, baseband. And we just saw already, also in your presentation, Jack, these two different ways of acceleration. That, of course, leads to a very nice competition area. Now we have these specialized companies, Qualcomm being one of them. There are, of course, others there, which have slightly different approaches, but they compete on power. And whatever you do, we can leverage, and we can benefit from this expertise. And these guys know how to deal with power, and they have a complete different horsepower in designing silicon and upgrading silicon versus a traditional radio vendors doing his proprietary chips. And that's why I expect on the baseband, we will overtake the efficiency of SRAN within the next 2 years.
I agree. And I think that, the really important thing is to think about it in sort of in a longish term, not necessarily what's going on today. Not because you open up the opportunity and you don't necessarily are able to exploit the opportunity at the max on day one, but you create the background. So, Jack, you've been called on this. Do you want to comment on this? And then
thank you, Franz. I think you sort of you teed that question up very nicely for me, and I think you actually answered it for the most part. It's a lot of it comes down to the hardware, and the hardware that Qualcomm is now shipping out to labs is designed again from the ground up to serve these workloads. There's a lot of flexibility in what we can do in terms of repartitioning and evolving over time, but it was designed to replace these more inefficient processors that were used in the early days, FPGAs and that sort of thing. And if you look at the ORAN white box designs, for example, you'll see 5 or 6 different accelerator designs allowed, which include GPU, FPGA, ASICs. We showed a demo at MWC last month where we were essentially using 16 to 18 watts of power to push a front haul at 3 terabits per second and to serve over a terabit of data to the UEs. And people looked at the demo and like, wow, we expected an awful lot more power to be consumed by this card, and the numbers obviously depend on the particular parameters and configuration you're using, but it was, orders of magnitude or multiples of the number that we're actually using. And similarly on the RU, I think we're also seeing this idea of artificial intelligence control over the power savings mechanisms. This is a very hot topic in the ORAN Alliance right now. There's multiple working groups looking at how to save power at the RU and how to allow the infrastructure, the RICs, the near real-time RIC and maybe non-real-time RIC as well, to configure power settings at the ORU and to have a more granular way of both serving your users so they don't notice any degradation in their QoE, as well as saving power. And I think that combination of artificial intelligence control and power savings mechanisms will be a nice thing that ORAN is enabling.
Absolutely, and but there is more than just power consumption from the hardware point of view. It's a question of how you manage power consumption end to end. Sushil, do you want to add anything to that?
So basically echoing what Franz was saying, right? So since it was an early stage or early days of development, our use for Open RAN was really big and they were consuming a lot of power. But over the period of last few years, it has come down to a place where it is very much comparable with the traditional vendors. And a lot of it also has to do with how the SOCs are evolving toward lo-fi processing in the RU. So that size have come to I would say a very comparable space, especially on silicon is a very I would say one of the most competitive area today in the Open RAN. That's where most of the bigger companies are competing, and it's competing for good, right? So there are ESIC based solution coming in, and then there is CPU based solution coming in. Companies like Qualcomm, Intel, Marvell, they're pushing leading edge technologies in the Open RAN ecosystem, which is further going to benefit, right? Today, 3 nanometer lithography based systems are being pushed into the Open RAN system, which gives us a massive power saving, also give us larger performance. So now we are able to accommodate more number of cell into the same size of silicon or even smaller size of silicon if you compare it for last 5 years, right? So the capacities have gone from I would say at least 5 to 6 fold from where we were back in 2018, right? So that's one area where ORAN as a technology is evolving, and all the vendors are putting up very strong competition, and that's how the performance and I would say power consumption efficiency is I would say very much comparable to the traditional network, and to an extent going to break that barrier. Open RAN will soon be better power efficient than the traditional network because of the pooling gains and all that.
Absolutely, because the more opportunities you have, the more freedom, the more you can optimize. You don't have to, but you can. So I guess it's a huge enabler. We have another question from the audience on REC. Clearly, as you mentioned, it's quite important. It's not mandated, but it's critical. How do you say? Can you give us a sense of where we're at with it? What are the prospects? Who wants to start? Franz, why don't you get started on this? Franz, are you okay? Do you want to take that, the REC question?
Can you? I think my connectivity is a bit. Can you repeat the RIC question?
Oh, yeah. So the big question is that can you tell us where we're at with RIC? You mentioned before it's important but not mandated. But how where are we standing? Where are we going?
Okay. Yeah. Yeah. So let's see. I hope my connectivity is good enough. So RIC is two things, right? Non-real-time RIC and near real-time RIC. Non-real-time RIC is pretty straightforward because it's part of the SMO, and that one I think will be basically part of the deployments relatively from the beginning, because the standards are relatively there. You are part of the SMO. The near real-time RIC, as said, is a bit more difficult because standards are not fully matured, and this is really the thing we want to drive because it's important that the RIC becomes a platform. So if RIC really comes as we envision it, it would change the radio to become a programmable platform. So you really could, with an XAP and RAP or both, start to really influence the behavior of a certain device in a certain area, in a certain network slice, and whatever else you can think of. Yeah, and this, I always say, it's maybe not the perfect comparison. It's a little bit like App Store or Play Store. You can use smaller companies which are not so deep in all the radio details, but you can use them to develop certain apps to influence customer behaviors in relative short amount of time. So really you can start to tailor the customer experience for certain customer groups within weeks or months in a perfect picture by working with such companies. And that's a complete game changer. If we manage to come to that point, that is a complete game changer, how networks can be used, how network can be tailored to customer demand. But as said, especially for the near real-time part, where we talk less than 1 second interaction time, we still need to make significant progress also in Oran Alliance to come to that similar set of APIs and interfaces, so that the CUDU really are also exposing the same capabilities to the near real-time RIC. That's the biggest piece we need to come over.
Sushil, how about you? What do you think?
So I think RIC is basically what every operator is looking forward to. I mean, this is one of the platform for which is basically a motivator for doing Open RAN. Otherwise, nobody was very upset with the way the network was built. Everybody wanted to have that freedom to, because every operator is different. You know, even a big group company operator, every country, or I would say every market, every city, or every network cluster is different, right? So they have their own different need, the way we operate that network, the way we optimize that network, the way the performance of that network is. And that's where the customization piece was very critical, where all operator wanted to move into an era where they can customize their network based on their need. And RIC basically provides that platform. Now, as Franz mentioned before, there is a big construction site there, which is basically having a standardization of the interfaces on RIC. Near real time would probably be realized, later part of the 6G, but non real time and near real time is something that can be done relatively faster. I would say in 5G itself. Non-real-time RIC will be productized. Oran Alliance has done a good job there with putting together a standard framework for RIC, which can be adopted by multiple companies. And a lot of companies are taking that open source reference code and trying to build on top of it. So I personally believe that RIC is definitely going to be in the top list of all the operators which they want to deploy along with Open RAN. Timing is something that will depend upon the maturity of the product.
Great, Jack. Final comments from you.
Yeah, very briefly. I agree with Sushil and Franz and their comments. And the RIC platforms are one of the most exciting parts of the ORAN architecture, and we are seeing it being productized. I know on the non-real-time RIC and SMO, Qualcomm's doing it. Other companies are doing it. And I think the comments are right that that'll be the first step, and then the near real-time RIC will be next. But if you think of the O-RAN architecture as open front haul and RAN intelligent controllers and all the interfaces that are being defined are allowing us to do all these things that previously had been very vendor specific, and now we can have a system that manages equipment coming from multiple vendors, and that's what's a major step forward, in my opinion.
Okay, we are out of time, but I'm going to ask a very, very quick question to all of you. Is the RAN of the future, going to be all open? Some people think, well, just a little bit, but not all of it. What do you think? Is it going to be all open or not? Sushil, why don't you start first?
I mean, open for sure. Again, all the operators, all the vendors have a place. It is basically the philosophy how you will build the network. It's not about A vendor, B vendor, or categorize. It's not about categorization of vendor. It is all about how we adopt an architecture, and it is definitely going to be open.
Franz?
Of course, it depends a little bit how you define open. But in principle, it's a complete no-brainer. Of course, and I would put it like that: all the key interfaces and APIs we have in the network where we want to have flexibility and be able to mix and match will definitely be open. That's a complete no-brainer. That's clearly our target, what we are pushing for as DT.
Jack?
I will give an unqualified answer. Yes, absolutely, 100%. We just have a few small hurdles to get over and a few companies we need to convince to come along with us. But yeah, we're going to do it. Yes.
Absolutely. That looks like the future looks great. And we have some work to do, but that's all the fascination and the great thing about new technologies is that there is work to do, but eventually we'll get there. Well, thank you all in the audience. You asked great questions, and to my panelists, they gave us great insight into what are we up with Open RAN. So thank you all, and see you next time.